Hi everybody, it's Mrs. Mancuso. I am going to continue working on the January 2018 Chemistry Regents exam with you, question by question. So we are now on part B1, more multiple choice. An ion that consists of 7 protons, 9 neutrons, and 10 electrons has a charge of. So it's got 7 pluses. The neutrons are neutral, so I can just cross that off. 10 electrons are 10 negatives. So I have 3 more negatives than positive, so that would give me a -3 charge. Which electron configuration represents the electrons of an atom in an excited state? So first of all, 3 of these choices are going to be ground state, which means I can look them up on the periodic table. 2,2 is on the table. 2,8 is on the table. 2,8,1 is on the table. 2,2,1 is not on the table because something has moved out. It used to be 2-3, and now an electron has moved to an excited state. The table below gives the atomic mass and the abundance of 2 isotopes of boron. Which numerical setup can be used to determine the atomic mass of the element? So I want to multiply this times this, and I want to add it to this times this. So I go down here and I look for that. 10.1 times 19, 11 times 80. Okay, here we go. And then I definitely need to divide by 100 because this is a percent. Okay, so there's my choice. I never divide by 2, and these ones already moved the decimal, so if they already moved the decimal, I can't divide by 100. In which group on the periodic table, so I'm looking at the groups going down, would a non-metallic element belong if they tend to gain 2 electrons? So I'm not looking at the left side. Left side are losers. If I'm gaining 2, I want to be 2 from the noble gases. So the noble gases are group 18. If you go over 2, that's group 16, and group 16 all has -2 on it because they gained 2 negatives. Which trend is observed as the first 4 elements in group 17 are considered in order of increasing atomic number? So that means I'm going down group 17. So as I go down group 17, which one is true? Electronegativity increases. No. Your ability to attract is going to decrease because you're getting larger in radius. First, ionization energy decreases. Yes. So ionization energy is how much energy would it take to get away your outermost valence? Well, if you have a really large radius, it's going to be easier to get your outermost valence away from you. So that ionization energy is going to decrease. The valence electrons would be the same, and the number of electron shells would increase, not decrease. What is the number of moles of KF in a 29-gram sample? All right, I'm going to go right to table T, and table T says number of grams is equal to grams over gram formula mass. So let me erase that so I have a little bit of room. I want grams over gram formula mass. So my grams are 29. My gram formula mass, I need to add together a K and an F. So I'm going to the periodic table and I'm looking up how much a K is. A K is 39 and F is 19. So I'm adding together 39 plus 19, I get 58. So I want 29 divided by 58. Oops, sorry. 29 divided by 58, and I get 0.5, so it's 0.5 moles. Which bond is most polar? If I want to know about a bond, I need to look up electronegativity difference. All of these are with oxygen, so I look up oxygen first. Oxygen's electronegativity is on table S, and oxygen is a 3.4. So I want whichever one of these is the furthest from 3.4. So carbon is 2.6. Hydrogen is 2.2. So already I'm going to cross off 1 because hydrogen's already further from 3.4. Nitrogen is 3.0. Can't be that. And sulfur is 2.6. So my answer, the bond would be the most polar in the one that has the greatest electronegativity difference. That would be between H and O. Based on table F, so I'm going to turn to table F right away, which equation represents a saturated solution having the lowest concentration of ions? If it has a low concentration, it's probably insoluble. So 3 of these reactions are going to be soluble. I want to choose the one that's going to form an insoluble compound. So NaCl, Na is always soluble, so that works. AgCl, oop, there it is. Ag is not soluble with Cl, so that would give me an insoluble. If I look at the other ones, NH4 is always soluble, and K with Cl is always soluble. What is the molarity of a solution that contains 0.5 moles dissolved in 0.5 liters? So I go to table T and I look up the molarity. Molarity is equal to moles over liters. So I have 0.5 divided by 0.5. That would give me 1.0 molar solution. Given samples of water, so I've got 100 grams of water at 10 and 100 grams of water at 20. So the only difference between those two is their kinetic energy, and their overall heat is going to be different because there's more, this one's got a higher temperature. So sample 2 has molecules with lower energy, nope, higher. Molecules with lower velocity, no, higher temperature means more kinetic energy, so the molecules are moving faster. Less heat, no. More heat, yes. Higher temperature means more heat. All right, which particle diagram represents a chemical change? So I want to see something form an actual compound and really look different. That looks the same. This is just physical. That's just physical. That's literally identical. There we go. Here's a chemical change. I took a compound and I broke it down. This is decomposition, people. So that is definitely a chemical change. Based on table H, so I'm going to go and turn to table H right now. What's the vapor pressure of CH3COOH at 90 degrees? So first of all, I got to figure out what CH3COOH. If it's got COOH at the end, it's an organic acid. So in organic acid, there's ethanoic acid on here, and this has 2 carbons. So yep, I want ethanoic acid. All right, so ethanoic acid is this last curve. And so I go to 90 degrees. So I notice that the bottoms are read in increments of 5. So that's 75, 80, 85, 90. So I go to the 90, and I go up until I hit ethanoic acid. It hits right at this line, and over here, these are increments of 10. So 10, 20, 30, 40. So it would be 40 kilopascals. The arrangement of particles is most ordered. That means it has the least entropy. So the most ordered is in a solid. Solids are the most organized. So I would choose answer 4. What is the net amount of heat released when 2 moles of C2H6 are formed from its elements? All right, I need to go to table I. Table I gives me all the heat of reactions, and heat release tells me I'm going to have a negative value. So I want to go find the formation of C2H6. C2H6, where are you? Okay, I found it, and it's negative 84, and it makes 1 mole. So I want to take 84 times 2, and I get 168. So that's how much energy would be released. Do not be tricked by this 2 moles. If the reaction just makes 1, you're going to have to double it. All right, which compounds are isomers of each other? Isomers have the same molecular formula, but they have different structures. So methanol and methanol, this is going to have an OH on it, and this is going to have a double bonded O on it, so that's not going to be the same. Propanoic acid and pentanoic acid, prop has 3 carbons, pent has 5 carbons, that can't be the same. Ooh, that's a good one. 1 propanol and 2 propanol. So propanol is 3 carbons, but 1 propanol has the OH coming off the first carbon, and 2 propanol has it coming off the second carbon. So they definitely have the exact same formula, but a different structure leading to different properties. All right, the reaction between an alcohol and an organic acid. So if you have an alcohol and an organic acid, they come together and they form an ester. So I'm actually going to just make a new page here for a minute. If I have an organic acid, it has to end in COOH. And if I have an alcohol, it's got an OH on it. And what happens is the H comes off of here, the OH comes off of here, that's water, and I get this. I just connect this C and O to this, and so this unique thing is an ester. So that's how I figured out it was esterification. Why is potassium nitrate classified as an electrolyte? So to be an electrolyte, you have to either be an acid, a base, or an ionic salt, because you're able to conduct electricity. So not conducting electricity as a solid, you've got to be able to conduct electricity as an aqueous solution, and that means you need mobile charged particles, and those charged particles are ions. So acids, bases, and ionic salts all release ions when they're aqueous, which allow them to conduct electricity. When the concentration of hydrogen ions is decreased by a factor of 10, so here's my pH scale. The H's are the greatest down on the 0 end. The OH's are the greatest here on the 14 side. I've got 7 in the middle. If my hydrogen ions are decreased, I go this way, and a factor of 10 means my pH is going to go up by 1. So if, for example, I go from a pH of 3 to a pH of 4, I have less H pluses, 10 times less H pluses in it. All right, moving on. The cooling curve represents the uniform cooling of a substance starting at a temperature above the boiling point. So this is going to be my boiling point. This is going to be a gas because I'm above the boiling point. This is going to be a liquid. This is going to be a solid. And this is going to be my freezing point. All right, my question. During which time interval does it exist as both a liquid and a solid? So a liquid and a solid would be right here, minutes 7 to 9. If I could just review for a second, any place where there's a change in slope, my kinetic energy right now would be decreasing and my potential energy would be staying the same because I'm cooling. Here, where it's a plateau, and here where it's a plateau, the kinetic energy stays the same, but my potential energy is decreasing because I'm cooling it. All right, given this equation, what change in the reaction conditions will increase the frequency of effective collisions? So what's going to help my reaction rate become faster? So if I decrease the pressure, all right, I got to count up gases. I got 1 gas here, I got 2 gas here, so that gives me 3 gases on this side. And over here I have 1 gas and I have 2 gas, so I have 3 gases on that side. So that tells me pressure is going to not be affected by this reaction because I have 3 moles of gas on each side. If I decrease the temperature, so if I take away the temperature, I'm going to favor the forward reaction. So that is going to well, this doesn't really show it at equilibrium. I want to look at my other choices before I go picking that. Because usually if you decrease the temperature or something, the molecules move less, so I don't really want to do that. All right, increasing the concentration of the reactants. Absolutely. Anytime you increase concentration of a reactant, you're going to make it go faster. And increasing the volume would just make the molecules spread out more, so that wouldn't work. So again, I'm going to erase this little arrow I made because I don't have a reaction at equilibrium, I just have a reaction. So if I want to increase the effective collisions, I want to have more CH4 and more O2 to have the reaction happen more. All right, that is the end of the multiple choice, so we will stop this video and continue with another.